Hey everyone, this is Mr. Skelton. We are back for Unit 1, Lesson 3, and today we're going to be reviewing some Algebra 1 skills that pertain to really linear functions. So you have anything from writing a linear function given a situation, which you'll see on the slide right below the first one, going back to writing and finding the slope given 2 points, and then obviously doing some application of some linear functions through some word problems. And so what I really want you to do is turn to the kind of the last page where you have where it says linear function basics, and you'll see the 3 linear equations that were most commonly used probably in your Algebra 1 course, and that's slope-intercept form, which is y equals mx plus b. You have m being the slope or the rate, right? A lot of times, especially in situational problems where we have word problems, you have the slope being a rate, 5 miles an hour, right? That could be a rate. Or you're making $7 per hour. That can be your slope. It's constant, okay? B obviously being the y-intercept. Second thing is you have standard form, and that's where your a value and your b value with the a and the x are together on the same side. So for example, something like 3x minus 5y equals 15. And you're allowed to find the intercepts with that, but that's called standard form when your x and y value are on the same side of the equal side. And then one that maybe it's been it's been a year since you've had Algebra 1, but point slope form, you do a little of this in geometry, but point slope form is when you have one point given to you and a slope given to you. You can use what's called point slope form. And what you would do when you have a point of x1 and y1, so that being your point, you would plug that x value here, the y value here, and your slope would go right in for m. This y and this x stay as y and x in the equation. I'll show you an example of how we're going to use that in one of the problems coming up. Okay? I put some tips down here, for you. You don't have to follow these, but just some good reminders from your days of using linear function equations, and so you can read those as you wish, and then apply them if you can, and we'll apply some of them as we go. So let's head back to the first page, and we're going to move up to the second slide, and we're going to take a situation. You have 2 situations here, and the first one it says write a linear equation for Allie's profit after selling X number of hats, and then the second one is about the Saks swimming area, the auditorium, after X hours. So we'll take each one at a time and go through it, and these are some of the questions you may see on your assignment as we move forward. So here's what it says. After buying all of her supplies for $135, Allie began selling her stocking hats for $12 a piece. How much profit would she have after selling 25 hats? So the first thing we want to do is we need to come up with an equation. We need to write a linear equation. So y equals mx plus b that represents this situation, okay? So for me, I'm going to do something like this for profit because it says how much profit. So I'm going to use P. So instead of y equals mx plus b, since I have real world context here, I'm going to use P for profit. And how much is she selling her hats for? How is she developing a profit or creating a profit? She's selling them for $12 per hat. So I'm going to use H for hat, so 12H. Now, she had to pay out of her pocket $135. So the most common mistake I'm going to see here is students put a plus 135. Well, that would mean that you're adding $135 to her profit. Remember, she spent $135 already on supplies, so that would be subtracted from whatever profit she generates from selling her hats for $12. So there's our equation, that's part A, and then we're just going to plug in our 25H for that. And when you do that, I'll save you the drama, you're going to get $165. 12 times 25, subtract 135 from that, and you'll get 165. All right, let's go over to the next one. Well, here's what I'd like you to do on number 2. Go ahead and hit pause. Try it on your own. You already know the answers right here, so once you figure out your equation and plug in your 48, see if you get 57,600 gallons. Okay, so we're back, whether you pause it or not. Here's how we would set up this equation. So the pool, when it's full, is going to hold 192,000 gallons of water. When they empty the pool, keyword there, empty, they're subtracting water out. They can take out 2,800 gallons every hour. So we need to come up with an equation that's going to represent this situation. So I'm going to use L. And you can use any letter you want. I'm using L for left. How much water is left? Okay. Well, we're taking out 2,800 gallons every hour. Common mistake here is people will put this down. Okay. They'll put a plus sign here, which is correct. But the problem is, remember, water is being emptied or taken away, so there needs to be a minus sign in front of the 2,800. We're subtracting 2,800 gallons every hour, okay? Sorry, this should not be a G. You could use a G. It should be an H for hours, since that's what the time we're using, sorry. So there is my equation right there. How much water will be left after 48 hours? Take your 48, since 48 is representing hours. Again, I changed it back to H. Plug that in for your H. Take negative 2,800 times it by 48, and then add it, because there's that many gallons to begin with, and you'll get 57,600 gallons. We are on to the back page. Okay, it's kind of tough to read. You can kind of see it here. This section is called linear functions given 2 points. So when we talk about given 2 points, this is what I'm referring to, right? If you had, I'll give you an example, like 3, 4, and 7, negative 8, okay? That's your 2 points. And so what we have to do is come up with a linear function in example 3. This is a situation on number 3 where we're given 2 points. So it says, Tim's lawn mowing business has been profitable this summer. After mowing 18 lawns, Tim profited a total of $20. After mowing 33 lawns, he profited $395. Write a linear function for his profit. Now, when I look at this, in my head, right, I know it's linear, so I know I have to have a slope, correct? I have to have a rate. And when I read this, unlike the first two, I have no idea what he's making per lawn. That's what we got to figure out. And so the first thing I want to do on this problem here is take out the 2 points from this problem. So I have 18 lawns, and he made $20, and then 33 lawns, he made $395. Okay? So there's my 2 points. Now, again, in my head, I'm thinking if I want to write a linear equation, y equals mx plus b, I need a rate. I need to figure out what he's making per lawn. So from these 2 points, I need to find the slope. Do you remember how to find the slope? I'm going to cross this out since I'm not using those not to confuse you. Remember, slope is y2 minus y1 over x2 minus x1 from your finding slope days. So what you can do is label these how you would like, x1, y1, x2, y2. And I'm going to go 395 minus 20 over my x2 is 33 minus 18. Okay, so I got 395, get my calculator here, minus 20, you can do that in my head, 375, all right, over 33 minus 18, and I'm going to get 15 there, so 375 divided by 15, and I get 25. So what does that mean? What is that 25? That means Tim is making $25 per lawn, okay? Write a linear function for his profit, y, after mowing x number of lawns. Okay, we got this slope, right? We have this slope, but we need to be able to figure out what the y-intercept is. So what we can do is, we can do this in a couple different ways. If we know the slope is 25, I can pick one of these points, like the 18 and the 20, and I can just write out y equals mx plus b, and then plug my values in. So I'm going to plug in 20, since that's a y value, in for y. My slope is 25. The x value of my point is 18, and I could have used this point as well, plus b. So I'm going to solve for my b. So 25 times 18 gives me 450, so 20 equals 450 plus b, and I'm going to subtract 450. Okay, and so that's going to give me, what is it, 430? I'm going to have a negative 430 equals b. So here, this answer, and it took some time there to go through that, is going to be y equals 25x minus 430. Okay? So now when it says use your equation to predict his profit after mowing 50 lawns, what are we going to do? Well, we're going to take the calculator out, plug in 50. Remember, we said he's making $25 per lawn, so 25 times 50. That gives me $12.50 there. Get my calculator in view. And then I'm going to subtract 430. And there's your 820 right there. Okay? So that problem took a little bit of time, but hopefully made sense to you. So number 4 is a little bit tougher. Go ahead and hit pause and try it. I'll tell you right now, you're not going to get 2 points from this. You're going to get 1 point from this, and then you're going to see something else in the problem. Okay, so on number 4, it starts out with saying Samantha chews 6 pieces of gum per day. As soon as I read that, what does that tell me? Right? That's your slope. That's your rate. So in this problem, we had to figure that rate out. We had to find out that it was $25 per lawn. Here, they tell you the rate. Then it says we know that after 11 days, she still has 384 pieces left. Write a linear function for the number of pieces of gum she has left after X amount of days. Okay, so what do we have in this problem? We have a slope, and then we have a point. Now, if you remember from the problem I just did, right here, if you remember, I had found my slope, 25, and I used just one of the points, the 18 and the 20. You can use point slope form, which is right there, the number 3, or you can use what I did here, and I'm going to do again right here. For me, it's always easier, and I teach this, it's easier for me. Whatever you need to do, you do. I just write out y equals mx plus b, and I write in my slope, which we know, or excuse me, I'm going to fill in my y value is 384, right, xy, so 384. My slope is 6. My x value is 11 plus b. Now we're solving this for b. So basically 384 equals 66 plus b, so subtract 66 from 384. 384 subtract 66, and I get 318 is my b value. So the equation, the answer, is going to be y equals my slope, or my rate, that she's chewing 6 pieces of gum per day. That's a rate. So 6x, and then plus 318. Okay? Use your equation to predict how many pieces she'll have after 31 days. So I take 31, plug it in for x. 6 times 31, let's just double check, make sure I have it right, is 186, and then I add that to 318, and I get 504. Ooh, I did something wrong here. What did I do here? 384 left. Let's see here. Oh, I know what I just did. Okay, she is chewing 6 pieces of gum per day, which means the gum is being subtracted. Duh. So that should be a minus sign right there instead of a positive 6. We're not adding 6 pieces of gum to the total. We're subtracting 6 pieces of gum to the total. So let me go back here then, make that correction real quick. I knew I messed something up there. So that should be a negative 66 there. So I should add 66 to 384. So 384 plus 66 is 450. That sounds better. 450 is B. So this should be, I'll just rewrite this. Y equals negative 6x plus 450. Now let's double check just to make sure. Negative 6 times 31. That makes more sense, which is negative 186. And we're going to add that to 450 plus 450. And there we go, 264. Okay. Apologize there. Happens to the best of us, right? It's okay to make mistakes. Happens all the time. Moving on. So now we're going to get into a little bit of graphing. Again, this should be review for you from Algebra 1, but let's go through it. We're graphing a linear inequality. So this is in y equals mx plus b form already. And hopefully you remember that the first thing we want to do is plot the y-intercept, which is 4, so 1, 2, 3, 4. And then we're going to apply the slope. The slope is negative 2/3. Now, back when I taught Algebra 1, if there is a negative sign out in front, I usually put it on the top number. You can put it on the bottom number if you want. So I'm going to go down 2 into the right 3, down 2 to the right 3, 1, 2, 3. Now, when you're graphing inequalities, An inequality is the symbol here, less than, greater than or equal to, less than or equal to. You either have to use a solid line or a dashed line. And if you remember, if you have greater than sign or a less than sign, that's a dotted or a dashed line. If you have the or equal to underneath it, that's a solid or filled in line. So on this one, I'm going to have a dotted line. The other thing you need to remember about inequalities and graphing them is we're going to have to shade. Okay? You have to shade either above the dashed line or below the dashed line. And the quickest way to do this is just to pick a point either below or above the dashed line and test it. Your shade, remember, the way you shade, or the reason you shade, is because the shade always represents your solution set, meaning all the possible points in that shaded area could work for this equation. So I'm going to test 0, 0. It's usually the easiest one to test. So I'm going to test the point 0, 0, which is obviously right there. And if I plug in 0, 0 to this equation, and I get a true inequality as a result, that means 0, 0 is within the solution set. All right, so if I get 0 is less than, I know negative 2/3 times 0 is 0 plus 4. I get 0 is less than 4. Is 0 less than 4 a true statement? It is, which means 0, 0 is in the solution set, and you always shade your solutions, so you can just shade down here. Okay? Move on to the next one here. You can do this a couple different ways. You can use standard form. That is standard form. You can see that based on number 2 there. Oops, based on number 2 there, standard form. And that allows you to find the x and y intercepts. That's tip number 2. You can do that. Most students, a lot of students, when they're doing number 6, though, are going to just put this into y equals mx plus b form. So let's do that. I would subtract 4x, be left with negative 6y is greater than or equal to negative 4x plus 12. I'm going to put in slope-intercept for it. Divide by negative 6. And the reason I'm showing you this is because I want you to remember a small little tip here. Remember, when you divide by a negative number, what does that do to your symbol? It flips it, right? It flips it. So we're going to get positive 2/3. Negative 4 divided by negative 6. Negative divided by negative is a positive. 4 over 6 reduces to 2/3. And this is x, and then that's going to be a minus 2. So we're graphing that. So down 2, 1, 2, up 2, 1, 2, over 3, 1, 2, 3. Okay? And we have something that looks like this. Solid line. I know it's not perfectly straight, and the reason it's a solid line is because I have the or equal to line there. And again, we're going to test a point. I'm going to test 0, 0 again. And I'm going to plug in 0, 0 to the y equals mx plus b. So I have 0 is less than or equal to 2/3 times 0 is 0 minus 2 is 0 less than or equal to negative 2. Is that a true statement? Is 0 smaller than a negative number? It is not, right? So that means 0, 0 is not part of the solution set. So I know the opposite side of the line has to be the solution set. So I would shade this way. Okay? All right, last problem here. So when you turn the page, you'll see the linear function basics. And then I have one of these problems, which a lot of students dislike a lot from your Algebra 1 days, but we're going to go through this together here and see if you can remember. So you have a situation where you have 2 buses, okay? 2 buses leave Houston at the same time. They travel in opposite directions. One bus travels 10 miles an hour faster than the other. In 4 hours, the 2 buses will be 480 miles apart. How fast is each bus going? Okay, we're trying to figure out a speed. So these are your dirt problems, right? You probably remember this in Algebra 1, distance equals rate times time. Distance equals rate, which is speed, by the way. Your rate is always speed times time. Okay? And so the key to these questions is to figure out how you're going to set it up. Well, we have 2 buses. We have bus 1, we have bus 2. We know that in 4 hours, their total distance is going to be 480 miles apart. So what we want to do is we want to express this equation in terms of their distances. So the distance for bus 1 plus the distance for bus 2 is going to equal the total distance, which is 480. Now, we all know that distance equals rate times time. So what you're going to do, instead of putting a D here, you're going to express each bus's rate and time, or substitute. Since D equals R times T, you can plug that in here and here. So we get R times T for bus 1 plus R times T for bus 2, and we know the total distance after 4 hours is 480 miles. Okay? Now we want to pick apart what's in the problem to plug in for rate and time for bus 1. One bus travels 10 miles an hour faster than the other. Remember, R stands for speed, so I'm just going to put R plus 10. Okay? Now what does it say in the problem about time? Well, it says they left at the same time, and in 4 hours, the two buses were 480 miles apart, which means it took 4 hours to travel. So I'm going to put times 4 there because that's how long it took. Plus, now, if one bus was 10 miles an hour faster than the other bus is just going to be R, and the time for that bus was still 4. And so that's how you plug that in. Now you have to distribute the 4 through, so 4R plus 40 plus 4R equals 480. That's going to give me 8R, put my like terms together, plus 40 equals 480. 8R equals 440, divide by 8. So I get 440 divided by 8, and I get 55. Now, R equals 55, what does that mean? Is that the faster bus or the slower bus? Well, if you look at how we set this up right here, 55 is going to be your slower bus. We know the other one traveled 10 miles an hour faster, so the second bus, or the one that was traveling faster, would have to be 65 miles per hour for the second bus. Okay? Here's your lesson on linear equations and applications to those. I'm sure you'll have some questions, and that's totally fine and normal. I hope to answer those questions in class when you're working on your assignment, or if you have questions on the notes, I'd be happy to go through this again and maybe explain it to you in a different way. All right, look forward to seeing you in class. Take care.